Hello and welcome to this edition of Mr. Wood's Awesome Math Class. Today, looking at special right triangles, and today we're going to approach the 45, 45, 90 special right triangle, or in other words, an isosceles triangle. So we're going to look at the concepts and constraints that are followed behind these special right triangles and how to solve them. So here we go. All right, first let's just go through a couple of basic things that you really should already know. Well, we know that right triangles, in order to be classified as a right triangle, we know the triangle has to have what? It has to have some form of 90-degree angle in it, right? So it has to have some kind of 90-degree, or in other words, when we draw out a triangle, it has to have this little like box thing in the corner, meaning that that is a 90-degree triangle. Well, we know that, well, first off, we know triangles. Triangles always have to have what? All angles equal. So all the angles in a triangle have to equal what? 180. So we do know that. So therefore, these two could be anything that adds to 90. So any number that adds to 90. We know the longest side of a triangle is always called the hypotenuse. Right? That's the longest side of the triangle. And it is always across from the 90-degree angle. The other sides of the triangles can be called legs. So in the legs, we have what? We have one that's considered adjacent. So we have an adjacent leg. And we also have one that can be considered the opposite leg. Right? So we have the hypotenuse, we have an adjacent leg, and we have an opposite leg. And we also should know the formula for Pythagorean theorem. So if I wanted to be able to solve this, we can say, well, the Pythagorean theorem, or a squared plus b squared, is equal to c squared. So those are some things that you should already know. And what does the Pythagorean theorem help us to find? Well, we can use the Pythagorean theorem to find a missing side. So we can use it to find a missing side. So in other words, if you had a triangle and we knew two of the sides, so let's say I had a 5 and a 7, I could find the value of the other side, right? This special right triangle also gives us a way to find missing sides. But in a 45, 45, 90 triangle, the legs are the same value, right? So the legs are the same value, which means that also the angles are the same. Because why? In a 45, 45, 90, we're talking about an isosceles. So an isosceles triangle. All right, so once again, we know 45, 45 triangle means that it's an isosceles triangle, means that two of the sides are the same or two of the legs are the same value. Also means that the two angles that are opposite, the two angles besides the 90, so once again, I have a 90-degree angle, right? So I know that's 90. That means these two would have to be the exact same value, or in other words, isosceles. So if I don't have a 90, even if it's isosceles, if I didn't have a 90, the two of the angles would still be the same. All right, given these two scenarios, there is one way that, right, the way that you already know how to do it would be using the Pythagorean theorem, where I would say, well, this would be 5 squared plus 5 squared would have to equal x squared. Or in other words, 25 plus 25 would equal x squared, right? Or in other words, this would be 50 equals x squared. And if you square root that, we could say, well, that's what? Okay, well, that would be x equals Well, the square root of 50. Okay. Well, I'm going to, just for the sake of what we're doing right now, I'm going to break this apart. So I could break this apart to 25 times 2. So 50 is the same thing as the square root of 25 times the square root of 2, which would equal square root of 25 is 5 times the square root of 2. So what is this really? So this x would really be 5 times the square root of 2. So what did we really add? We just added the square root of 2 because we already had the 5. Okay, so let's see, do we do anything different in this scenario? So let's try that one now. So this is scenario 1. Let's look at number 2. All right, so this one would be what? X squared plus x squared equals 5 squared. Or in other words, 2x squared equals 25. Right? So then I would have to divide by 2, which that would give you then x squared equals 25 divided by 2. Now, if I square root this side, I have to square root both the top and the bottom. Well, I know this would, square root of 25, I know is 5. What I don't know is what is the square root of 2. Okay, so for right now, I'm going to leave that for just a second. So I know this x would be 5 divided by square root of 2. Okay, so now we know a couple basic things. We know that, so I can give our shortcut. So in scenario 1, what do? We multiply or add. So if you're given the legs and we want to find the hypotenuse, so if I'm given the legs and I want to find the hypotenuse, I would multiply by the square root of 2. In scenario 2, if I'm given the hypotenuse and I want to find the legs, so here we have to find the legs. Here we're trying to find the hypotenuse, right? I'm just going to write hippo. So find the legs, I would have to what? Divide by the square root of 2. So I'm going to divide by the square root of 2. And now let's put this into practice a little bit, okay? So here we go for example 1. The first thing we need to do is figure out, are we in scenario 1 or are we in scenario 2? Well, I got a 45. That means, so since this is 45, that means this one has to be 45 because that's 90. That means if that's 11, this has to be 11. So the only thing I don't know is the hypotenuse. So we know the 2 legs. We got to find the hypotenuse. Well, remember this. So this is scenario number 1, where really all I need to do is what? Add the square root of 2. So that means that here k would have to equal 11 times the square root of 2. And that is a little shortcut for special right triangles with 45, 45, 90s. Okay, now let's see example 2. Well, example 2, we know the hypotenuse. I know since this is 45, this has to be 45 because 45 plus 45 makes 90 across from the 90. We're also working with 45, 45s. And therefore, what do we have to do here? This looks like example 2, where I'm given the hypotenuse and I want to find the legs. So what would E and both F So E and F, we know E would have to equal F because they are the same. So since the angles are same, that means the legs are the same, or therefore it's an isosceles triangle, meaning the two angles are the same, the two legs have to be the same. All right, so we know scenario 2, in order, if I'm given the hypotenuse to go to the legs, what do I have to do? Well, I got to divide by the square root of 2. So here I just have to divide by the square root of 2. Well, what happens to the square root of 2's? Well, they divide out. So, but here, both E and F would have to equal 9. All right, so for example 3, once again, I'm given the legs. So I got a 10. That means this H has to be 10, because where's the hypotenuse? The hypotenuse is G, or across from the 90. So now I know that, what? We know that, so I'm given the leg, and what do I have to do? So this is scenario number 1. So in order to find this, we just have to do what? Multiply or put in the square root of 2. So this would have to be 10 times the square root of 2, and that is all she wrote. Okay, now I know the hypotenuse. This is example 2. So I know the hypotenuse. I want to find the two legs. So in order to do that, what do we have to do? Well, we got to divide by the square root of 2. Well, what I didn't do earlier, I cannot leave this way. Okay? We don't ever leave, this is what we practiced a little while back, we don't ever leave a square root in the bottom. Well, how do I get rid of it? We multiply both the numerator and the denominator by the square root of 2, because that would can't, in other words, this would give me a 2. So now in the numerator, I would get, I still have the 16, and we're adding in the square root of 2. And in the denominator, the square root of 2 times the square root of 2 is just simply 2. So now what I want to look at is, can I possibly simplify? So can you simplify this fraction? So what is 16 divided by 2? Well, I know 16 divided by 2 is 8. So that would be 8 times the square root of 2. So in this case, the legs, so both I, which is the same as J, is equal to 8 square root of 2. And that would be all she wrote. All right, at this point, what I want you to do is I want you to pause the video at this point. So do not go past this yet without trying these problems on your own. So pause it and try both of these. And then when you've completed both of those, then play the video and see if you got it right. So pause now, try these problems. All right, so let's see if you got this one right. Well, we know here we're looking at, so I got 6. This would have to be, the other leg would have to be 6 for A. B is our hypotenuse there. So I know if these two are 6, then I'm looking at here scenario 1, which all we have to do is do what? Add in the square root of 2, and we're done. So that would be what is the hypotenuse, B. All right, so on the second one here, I know I'm looking for the two legs. I've been given the hypotenuse. So if the hypotenuse is 7 square root of 2, in order to go backwards, we have to do what? Well, I got to divide it out. So this would be 7 square root of 2 divided by square root of 2. Well, those would divide out. So O, which is the same as P, because remember that it's an isosceles triangle, meaning these two angles are the same, meaning the two legs are the same. So they both have to be the same, and they both have to be 7. So O and P here would both be 7. All right, once again, I want you to try this out and pause this one and try both of these out. This one here is a little harder. So this one is a little harder. Just think about what you really have to do. Okay, think about what you really possibly have to do to make that one work. I shouldn't say hard, I should say harder. Okay, so pause it, try it out. All right, now for this, then once again, so I'm given the leg, so I know that f here would have to be 7 square root of 6. And in order to find the hypotenuse, we know this is scenario 1, because we're going from the leg to the hypotenuse. So I know I got to do 7 square root of 6. And I know I have to add in or multiply in a square root of 2. Well, when you multiply square root of 6 times square root of 2, well, that would be the same thing as saying 7 times the square root of 12, okay? Because it's just saying 6 times 2. So since they're both under the square root, they're like a like term. So similar to a like term, I can think about them that way. So that would be then square root of 12. Or e would, right now I'm going to leave it as e square 7 square root of 12. Technically, we should break this apart and simplify it. I know that this would be 3 times 4. So I'm just going to show you. I'm not going to require this of you, but I am going to show you. So I expect it to be in your notes. So 7, so I'm going to leave the 7 alone. Well, we know what square root of 4 is. So square root of 4 is the same thing as saying 2. So I'm going to bring the square root of 4 out as a 2 and leave the square root of 3 because I can't do anything with that. I don't know what that is. So really I can say that 7 square root of 12 is the exact same thing as saying 7 times 2 or 14 times the square root of 3. So really the true answer is 7 times 14 times the square root of 3. However, this would be acceptable for you for a test or a quiz for right now. Okay? And last one, we're given the hypotenuse. We want to find the legs. So I know this would be scenario number 2, right? So I could go backwards and say, well, I'm given the hypotenuse. I know I got to divide by the square root of 2. So that means I would have to rationalize the denominator and multiply the numerator and the denominator by square root of 2, which would give me 15 square root of 2 divide by 2, because square root of 2 times square root of 2 is 2. And that would be all she wrote because we cannot simplify 15 and 2. So here G, which is the same as H, would equal 15 square root of 2 divided by 2. And that is all you do for 45, 45, 90 triangles. Good luck and have fun.